Awesome. So I have to say that I've already been entertained today. Let's see. Oh, we're getting stretched. I got it. I've been entertained today because of Casey's presentation this morning, which went back to QuickTime 1.0. And as soon as he put his first slide up on the screen with the four-letter acronym RPZA or RPZA, I'm Canadian, I said, oh, road pizza. It's been like 20 years since I saw that. Being at Apple when QuickTime 1.0 was being produced was really an incredible, I think, thing to see. I remember we built a demo for the first launch that was done at Macworld, where we sent somebody up to the top of the Golden Gate Bridge and we shot a nonlinear video off the top of the Golden Gate Bridge. And that led to QuickTime VR some years later. And so it's interesting for me. I haven't had a career in video. I sort of went walkabout in between, worked on databases for a while, and a few other things, and now I'm back. So it's really nice to be here. And we're going to talk a little bit about WebRTC. We're the WebRTC sandwich. I know you had some sessions yesterday. I suspect tomorrow you'll be talking a bit more about it, some of the presentations about cloud. But since most of you have probably not heard of TokBox because we're a lot smaller than the other companies, quickly, we were founded in 2007. As you just heard, we're a Silicon Valley venture-backed startup. We introduced OpenTalk, originally based on Flash, but we knew it wasn't going to stay on Flash, so we actually hid the Flash from everybody. And as WebRTC came out, pulled out all the Flash components, replaced them all with WebRTC components, fully transitioned in 2012, and in fact, I guess the day that Google dropped Chrome 26, was it? Oh, what was the production release? 26, 22? 22 maybe. It's about right, that long ago. The day that Google went production with WebRTC, we went production with OpenTalk on WebRTC, which was actually really nice. And last year, about a year ago, we were acquired by Telefonica Digital. So I've sort of got half a head now that's Silicon Valley startup and half a head that's really large multinational telco. OpenTalk itself as a platform, all it's trying to do is make it really easy for developers to add WebRTC video to any website or mobile app. It's that simple. We deliver APIs, we deliver a cloud, we deliver event models, we deliver a bunch of stuff like that. In a Silicon Valley web sense, I think of ourselves as a platform as a service, a PaaS. In a telco language, because I'm now bilingual, we're an over-the-top video service. It's the best way to think about us. So I'm just going to skip this slide. The thing I'm going to talk about is what we've been learning from customers. I'm not going to talk about the standard itself. I'm going to talk about what we've been learning from customers. Because as we've been deploying solutions for real-world customers, we learn a lot about what people really want to do with WebRTC. And it turns out that, in fact, most customers don't want to build a communications service. They don't want to build WhatsApp. They don't want to build Skype. They don't want to build BitTorrent. They want to build something that has meaning for their business. Communications is a great business. It's worth, more than $1 trillion. But there's a lot more business out there which communications enables, which is, in fact, the business most of us are in, enabling communications. And what they want to do is they want to implement customer service solutions. They want to get closer to their customers, let people engage with their brand in one way or another. They want to do diagnosis remotely if they're in healthcare. If they're in education, they want to do it over distance. And each of these different industries and different verticals, they show up at the door with this WebRTC standard, and you immediately start to use it for things that aren't in the nicely prescribed set of use cases that the standard is designed to implement. And that doesn't stop them because they don't read the standard. They just say, WebRTC, video, let's go, let's make it happen. The biggest thing that all these customers have in common, and what is so exciting to us about WebRTC, is that none of these customers want to be experts in real-time video. Their business is to be experts at something else. And what WebRTC really starts to make possible in a way that we believe is fundamentally transformative compared to all the previous standards work that's been done around video is that by bringing it out into the level of the browser, it makes it accessible to people at a level, at a common denominator where people don't need to be expert. They shouldn't need to have to be expert, and we have really the possibility to make communications technology around live video actually disappear. And if we can make it disappear as a technology, then we're going to see it embraced in places and ways that, you know, for the past 20 years in video communication and in collaboration technologies, we've been trying to make happen, that we really believe that WebRTC as a standard has the possibility to make that happen. And so, you know, what we really want to do is move beyond the ordinary, move beyond the simple peer-to-peer web-enabled case, which is what WebRTC does incredibly well, because it turns out that's not really what the real world wants. When the real world starts to build things, they start to run into challenges with WebRTC. And I know Dan yesterday talked about a diamond that needed to have some polishing. We actually think the diamond's pretty good. It's just, it's a diamond. It's not an entire necklace. And it's not so much the diamond needs polishing in our views as people want necklaces, not diamonds. And these are the kinds of things that people end up wanting. And it all depends on the use case. Some people want more than peer-to-peer, more than one-to-one conversations. Some people need to record conversations in the cloud. Other people, you know, need to deal with low bandwidth situations in a way that is challenging for WebRTC. And those are kinds of things that, in some cases, we can actually make work within the constraints of the current standard and the current implementations. And in other cases, work actually needs to be done on the standard or in the implementations. And I'm going to highlight some of those things here. So I'm going to really spend the time talking about 3 applications. And we're going to go off the beaten track. I'm not going to talk about, you know, connecting to a Chrome browser to a Firefox browser and having a nice straightforward conversation, because that can be done. That's pretty straightforward to do. And all of these are from real-world examples. I'm not going to use customer names, mostly because the customers aren't ready to be talked about yet. But this is all fairly leading-edge stuff. The first one actually turns out to be the same as the last talk, which is robots. Robots are always fun to talk about, so we're going to talk about robots. And I think actually that if you look back at this decade, at the end of it, that you will conclude that this was the decade of the robot. And I mean that because I think in the year 2010, robots, like, you know, were a concept that people were familiar with, but by the year 2020, you will all have robots somewhere in your life one way or another. And there's 3 real enabling reasons for that, none of which have to do really with communications per se, but one is that smartphones and tablets have really created a mechanism by which robot manufacturers can put brains on a robot faster, cheaper, and easier than was ever before possible. And those brains are now programmable in ways that are simpler than was ever before possible. The second thing is that we have high-performance Wi-Fi just about everywhere, and where we don't, we have 4G everywhere, and those 2 things are enough to carry live video around to a robot that's moving around the room or around the house or, you know, around the neighborhood. And the third is something we're interested in, which is WebRTC makes real-time video very, very accessible. So actually, the guys on the right at the bottom here, and one of the things that's interesting, actually, if you look at these 2 pictures, we work with a bunch of robot companies. One of the things you'll notice about those 2 pictures is they both have Apple devices sitting inside their robots. And one of the things that we all know is that Apple is not a great place to try and have your WebRTC running at the moment. And yet it's what people want to pretty much stick on their robots. It's not a huge problem, but what it actually highlights is some of the things that are most interesting about WebRTC have nothing to do with web. Because in this case, the head of the robot is not a web device. It's a native app that's running in iOS. Fantastic. That's actually pretty straightforward to do. We can take Google's reference implementation, build a wrapper around it, create an SDK. You can build native apps for an iOS infrastructure, and your robot vendors are off to the races. What's important here is not the head that's on the robot. What's important is the person who's at the other end controlling the robot is more than likely sitting in front of a web browser, and they didn't have to install anything to actually control and be the person that's on this robot. But it's the first thing that makes you realize that WebRTC is not just about the web. And it is bigger than the web, and bringing the web to this mobile world is actually empowering a new set of use cases, which I'm pretty sure were not high on the list of the standards group when they were starting to think through the formal use case list. Robots not on list. And yet, they're incredibly powerful. If you have these things running around in your office, they actually change the complete dynamic of your office. And right now, if Silicon Valley is the future, I've been recently looking for more office space in Silicon Valley. So I've been going around looking at one space after another. And in some cases, you look at space before the previous companies have left because they know they're leaving and the space is being leased. And it's kind of funny because we power these things. And I swear, half of the companies that I visit have at least one of these things wandering around in the premises already in Silicon Valley. And it's not because it's cool. It's because we have spread out organizations, and the ability to project yourself through a movable robot is actually incredibly powerful in maintaining presence in an environment. But the takeaway for WebRTC, as I said before, is there's more than just web to WebRTC. We need device support. We need connectivity that can get through firewalls, because the next thing that happens is when you just drop a robot in an environment, people expect it's going to work on the local Wi-Fi. So things like TCP fallback actually become incredibly important, something that's kind of coming in the implementations. Unevenly distributed across the WebRTC implementation space at the moment is probably the best way to describe it. So that's kind of a little bit in the future. Now let's get a lot more prosaic. Number 2, insurance claims adjustment. How many people here have been in an automobile accident? I was in one once. Kind of made a mess of my car. So you think that the worst thing about being in an automobile accident is actually being in the accident. And then you actually have to go through the insurance claims process. And you realize that the actually getting your car fixed is way worse than the actual accident was, because the accident takes seconds, and as long as you're not injured and you get over the shock of it, that's kind of over. But the insurance claims process drags on forever. And what normally happens is, you have your dented car, and either you drive it to a claims adjuster at an appointed hour, and they look at it, and someone decides it's going to cost, $1,600 to get your car repaired, or $16,000, the case may be. Or what's worse is they send the claims adjuster to you because it's supposed to make your life easier. And now it's like waiting for the cable guy to show up. You're like, well, they'll be there between 12 o'clock and 4 o'clock in the afternoon. It's like, I'm at work between 12 o'clock and 4 o'clock in the afternoon. Can they come to my work? Well, is your car at work? No, it's not. It's like, all right. So it gets worse. So we're working right now with some folks who are trying to make claims adjustment easier using WebRTC. And what they're trying to do is make the customer their own claims adjuster. So they put the claims adjuster on the other end of the live video link. They send the customer out to the car to show them the car through live video. They tell the customer what they want them to look at. They take pictures of the parts of the car they need for the insurance record, and they do the claims adjustment completely remotely, which means they do it on demand when you want the claims adjustment to happen. It takes a process from being, I drive somewhere, wait while someone does it, and leave, or I wait 4 hours. It brings the entire process down to 10 to 15 minutes at the time that is convenient for you. So this is a massive business win, and it's a massive customer win. It saves the business money, because they don't have to maintain claims centers, and they don't have to send anybody out to see you. They just get to maintain people back at the shop, so to speak. And it saves you time, which makes you happier. This is like a very unusual thing that happens. The business saves money, and you get happier. It doesn't happen very often. So that all sounds very easy. We call this use case See What I See, because instead of using WebRTC for video conferencing, we're using the front camera on the device. You're actually using the device as a remote camera, and the other person is seeing what you're looking at. And this seems all very straightforward. until you actually try to implement it. And then you realize that life is more complicated than you think. Because the first thing you need to do is, well, you want to be talking to the rep on the phone, the claims adjuster on your phone, looking at them, and then you want to show them what you see, which means on the fly, in the middle of your WebRTC session, you want to switch from the front camera to the back camera of your phone. That can be a little more complicated. Most recently getting a little simpler in the last couple of days, but has been quite complicated to do for some period of time, because switching cameras in the middle of a live WebRTC session is not something that had previously been available in the standards. You end up having to tear down the connection, recreate the connection. It creates this user experience which is very disjointed and really bad. So that's the first problem. We want to be able to switch between cameras. Very technical detail, almost, and yet it's right at the core of the use case. It's the kind of thing that when you're on paper working it all out with the customer, it all sounds great, and then when you go to actually build it, you discover you can't build a perfectly good real-life use case. The second thing, which is more troublesome, is you discover that what they really want is they really want a high-resolution camera grab of the car. They don't want, a video resolution grab that comes over they want a 4K by 3K image off the camera on your phone. Well, in general, WebRTC is not so happy. The WebRTC pipeline is not so happy if you set up the camera in your phone to be throwing 4K by 3K at the front end of the WebRTC pipe saying, please give me some real-time video at the back of it. It says, no, I want a lower resolution. Which means in the middle of your live video stream, when you say, stop, now I want a 4K by 3K static image off this camera, these two things do not add up. You can't do them at the same time. So you go back to the drawing board again. You have to tear down the WebRTC pipeline, grab the static image, put up the WebRTC pipeline. And the entire process here is all about the remote claims adjuster being able to use the customer as a remote cameraman. Move the camera a little to the left, closer in, just like that. Right, hold it there. Bam, let me take the picture. Okay, good. Let's go on and take the next picture. And when that entire process takes longer because we're tearing down pipelines and disconnecting things and switching to the camera, all of which should take like just a few milliseconds, right? No, it doesn't. Then that process falls apart. And then the third part of the problem that becomes pretty interesting is the next thing, of course, that wants to happen is the adjuster remotely wants to make sure they've got the right picture. So don't mind, at the same time as we're streaming live video off your phone, stressing this phone to within, an inch of its life, just hold the horses. We're going to move a 3 megabyte picture upstream at the same time so that they can look at it live back at the central facility. These are the kinds of things that happen in the real world when you want to build interesting applications that push the envelope. All of those things can be worked around, but they're all the kinds of things that take something from being I could build that in a day, to all of a sudden like, oh, that took more than a day to build. This is a major engineering project to figure out how to make these things happen. But what comes out the other end of it immediately is business value and customer value all at the same time, something that makes an impact when you can make this kind of thing work. And if you think this is all just about insurance claims, it's not. Insurance claims is actually a pretty big business, but you can take this exact use case and apply it to US government customs inspections. Because it turns out when something strange comes into the docks in Baltimore and somebody opens up a container, and on the inside of that container what looks like an antiquity that's being shipped in from, I don't know, Thailand or somewhere like that. The antiquities inspector is probably not on duty in Baltimore at that point in time, but there's probably one of them available maybe on the West Coast or up in New York or down in Miami, and when they can connect those people in real time, they can make the entire customs inspection process go faster. So this entire idea of see what I see, camera, image capture, all those kinds of things has actually got a fairly broad application and in each case generates real value. Example number 3. This one's really simple. Education. Most of us have probably built video solutions that power distance education. It's exactly the kind of thing that we know how to use video for. It's exactly the kind of thing that WebRTC is really stressed to deliver today. And it's because WebRTC is primarily a peer-to-peer solution that is targeting, small audiences, and in a classroom or tutorial setting, you have to think about a multi-point solution, which means scalable traffic. You somehow have to go through the cloud to do it. You have to implement cloud solutions that can take streams and scale them out, and then you have to deal with all sorts of issues, whether they're speaker support, bandwidth adaptation, dealing with low-powered devices at the receiving end, et cetera. And so we call them LCD challenges, not liquid crystal displays, but lowest common denominator challenges. And that has a lot to do with how you take WebRTC signals and adapt them over time, at least until, of course, if we get VP9 with SVC, we might have some nicer solutions. And just to show you the kind of things that we're doing in the cloud right now, this is our techie chart for the entire presentation. If I try to explain this chart, this is aggregation of about 4 weeks worth of traffic that were on 4 weeks worth of multi-point traffic, so a classroom style setting where there was one or more devices that were low powered and were creating congestion in the entire network. And as a result, that their demand to sort of reduce the bandwidth of the WebRTC signal that was being originated from the classroom was causing everybody else's experience to be pulled down. And what you can see going on here is actually the bandwidth. That was good. Hello? Let's go back. Video? Okay. You can see the bandwidth being slowly dragged down on the left and then actually starting to fall off the cliff, at which point our cloud, which is monitoring all these things, detect that that's happening, does something specific to the troublesome connection that is pulling down everybody's connection, at which point the WebRTC signal everybody else is receiving rebounds and goes up. This isn't exactly rocket science in traditional video conferencing, but in WebRTC land, this is pretty much rocket science today. And so some of the things that are going on in WebRTC is taking all the learnings that have been built up over the last several years, over the last several decades, honestly, in the video world, in the video conferencing world on top of H.323 with MCUs, et cetera, and figuring out how do we take those things and move them in a web-compatible manner, move that knowledge into WebRTC implementations. And this kind of capability is the sort of thing that is, at this point, bleeding edge in WebRTC, and there's more of this kind of thing to come. So went through 3 examples, robots, insurance claims, and remote classrooms, and talked about in each case how they sort of push the envelope of what WebRTC thinks it is, going more than web, really talking about camera manipulation and what that takes, multi-point traffic shaping for classrooms. And the good news is we can do all those things. There are still lots of implementation gaps. This is the necklace, I would say, as opposed to the polishing, right? We want TCP transport fallback. Chrome has it, Firefox doesn't. We want H.264 support to make phones work better and work faster. We want more browsers to support it. That would be nice. We'd like to have some improvements in quality management for multi-point streaming cases. Right now, the reference implementation for VP8 that Google ships lacks temporal scalability support in VP8, which is something that could make multi-point easier for us. We need archiving for regulatory purposes for certain use cases. All of these kinds of things are in the future for WebRTC. The problem is customers want them now. And the good news is many of these you can work your way around with various forms of cloud support, and that's what we end up doing, and that's what we get customers online with. But over time, these are the kinds of things I think you're going to see WebRTC start to deal with in the standard itself. So to me, The good news is you can do this today. And wrapping up, the last thing I would say that I think really bears thinking about, because having come from the web world in San Francisco and now working for one of the world's largest telcos, I can tell you that WebRTC is absolutely the first real-time communication standard that is moving at the speed of the internet. And the reason that is it's the first real-time communication standard that doesn't need the deployment of hardware to succeed. It's going through the internet on top of everything that's already there, which has allowed us to go from 0 to 1 billion WebRTC endpoints in about a year. It took 16 years to get to 1 billion mobile phones. It took a year to get to 1 billion WebRTC endpoints. We'll get to 3 or 4 billion in the next 3 or 4. That's going to change things faster than anybody who has worked with the communications industries really understands. And that's a place where the telcos really need to grasp sort of the internet view of the world to understand the rate at which this wave is coming through. Thank you very much.